Hi everybody, thanks for watching. This is a video walkthrough of the Internet Movie Database example, the IMDB example. So I've already loaded the IMDB example Jupyter Notebook into the Google Collaboratory environment. We can check the runtime from this drop-down menu. We can look at a runtime and we're running Python 3, and I selected the tensor processing unit. I think it's a little bit faster than the GPU. So go ahead and save it. So this tutorial is adapted from our textbook that we're using, Deep Learning with Python, Chapter 3. I always like to start my Jupyter Notebooks with this bit of code. It sets the screen so my cells fill the screen, or at least they're filling it to 95%. And I like to be able to see the full cell width that way. So this example of the Internet Movie Database is prepackaged in the Keras library. It has 50,000 training and test reviews from the Internet Movie Database. And we're going to use a deep neural net to classify the reviews as either positive or negative. So we have two classifications here. So it's going to be a binary classification. Positives are going to be 1, and a negative review is going to be 0. So we're going to go ahead and import the necessary packages. Unfortunately, there is the Internet Movie Database data set from the Keras library is incompatible with the most current version of NumPy, so we need to downgrade NumPy to 1.16. And so this little bit of line right here is going to install the lower version of NumPy, and that way it'll be compatible. And then we're going to load the data into train data and train labels. So this is like our train X and our train Y, and then our test data and our test labels. So it's our test X and our test Y. And then we're going to import only the most common 10,000 words. And this is going to help our analysis. That way we don't have words that show up in only one review or show up once in our 50,000 data sets. So with that, we can go ahead and run the cell. And now when we downgrade our NumPy, we're going to get something that says we need to restart the runtime. And if you are doing this on your home computer in Python, you're going to have to also download that NumPy. So I would recommend doing this little bit of code. So now we're going to restart the runtime by clicking here and then say yes, because the packages were imported, but we need to restart it. And then once again, we can run that cell. And then now we have the quick version of NumPy already installed, and we are going to be good to go. So let's look at our data. We'll print the first 10 or 11 training labels. So again, here are training labels. They're 1, 0, 0, 1. So the ones are positive reviews, and then the negatives are, or the negative reviews are 0. And so these are just the first, I believe these are probably 11 here. And then there's going to be 50,000. That's going to be the length of that. Oh, I'm sorry. It's going to be 25,000 because we're splitting it. When they get split into the train and test, we're splitting it 50-50. So that's actually the length. We have 25,000 training data points. I can go and run these. And then now here are the words. So here are the word indexes for our 10,000 words. So we have 10,000 digits. So each of these digits corresponds to a word. So here's our training data. And then now we can get the word index if we want. So from our library, we can get the word index and we can print it. This word index, WI, corresponds to the word and the actual index number. So anytime font is shown, it's word number 34,701 in our index. And remember, we're only taking the 10,000 most common words. So our index is only going to go up to 10,000, but we can look at the entire word library this way if we want. And then now we can come back and find the word that corresponds to that index using the operator function here. And so now if we go ahead and run this, shows us 10,000 lines of, or 1,000 lines of code. And so these are all the different words, and this is the word index. So, you know, word index 972 is the word joke. And I think they're ordered in frequency. So as we get up high, the is the most frequent word in our data set, and so it has the word index number 1. And remember, we have 10,000 of these. And then if we want, we can convert the word index back to a written review through this line of code. I'm not going to necessarily walk through that code, but now we can see. And so this bit of code right here from our second review this is the written review. And so it's kind of funny. You can tell that it was a bad review, and so we can automatically classify this as being a bad review. But we're going to try to do this with neural net, and we can look at the sixth one too, and now we can look at all of our word index, and so you can pick whatever one you want. And look at what the review was. All right, so right now what we have is a single vector that's 10,000 words long. We can't put that in a neural network. We need to convert it to a tensor. And so now this is going to create a tensor that's 25,000 from all of our training samples, right? We have 25,000 training samples by 10,000 words. So 25,000 number of samples, 10,000 number of words, and then the tensor of all zeros except for ones where that word is in the review. So we'll go ahead and define our function, and then now we can apply it to the data. So what this is saying is each of our 25,000 reviews are going to be are going to have a vector that's 10,000. That's going to have a length of 10,000. And so, you know, our reviews don't have 10,000 words in them. They have many fewer words, and so most of our tensor here, or a vector, is going to be full of zeros. And then it's only going to have a 1 where that word was written in that review. And then now we can kind of see what that might look like. Oh, we already ran that cell. So here's the shape of our training data. It's 25,000 by 10,000. And then now we can see the words that were in that review for that first training data. And then it has 2 dimensions. And we can look at any one of those training data and find the reviews, the word vectors that they have. And so you can see that most of these have very common words at the beginning here. But if we go higher than 25,000, we should get an error. And then because it's out of our index size. So we can pick whatever review you want to look at and see what the word index was for it. And then now we need to convert our targets to floats. This way we have a finite number of decimal places. It's always a good practice. And then now we can import some more Keras libraries. So we're going to import the models and the layers, dense and flatten. I don't think we're actually using flatten quite yet. So we're going to build a model architecture. So the input shape must equal the number of vectors or unique words. And then we're going to have one hidden layer. So here's our first hidden layer. And then it's going to have 16 hidden units in it. We're going to keep our activation function to ReLU. And then our output function is going to be sigmoid. Sigmoid we use for binary classifications because we're converting everything to a value that's between 0 and 1. And then we're going to compile the model with atom optimizer, binary cross entropy, because we're doing a binary classification problem, and then the metrics are going to be accuracy. And then it's always good to split our data into training and test data. In the book, they do this manually, but it's much easier to use the sklearns package, which we imported up at the beginning. So the sklearn train test split is a great way to create validation data. And so that's how we're going to create our validation data. We're going to split the training data and the Y data, or the X training and the Y training, to 20%. So that means 80% of our data is going to become the training, and then 20% of our data is going to become the validation. And then we're going to shuffle it. So that means we're going to take, remove our 20% randomly throughout that sample. That way we're not taking the bottom 20% or the top 20%. That could be a problem if the database has all of the positive reviews at the beginning and all the negative reviews at the bottom, or vice versa. So we want to make sure we get a random selection, and that's why we're going to select shuffle. And then it's going to split it into the training data, the X block train and the X validation, and the Y block train and the Y validation. And then now we're going to fit the model to our training data. Again, we're going to use the X train and the Y train. We're going to use 20 epochs, and a batch size, we're going to do 500 samples at a time. And our validation is going to be the X valid and the Y valid. And so now as we go through our epochs, we can see our accuracy on our test data, and then the accuracy on the validation. And then we get the loss and the validation loss. And then notice we save the model as history. This way we can pull up the model details, and all the model details and the output is going to be saved under this history here. And so you can see how their accuracy is approaching perfection. So we're overfitting our data now, because our accuracy on our test data is perfect, but our validation accuracy is kind of maxing out at about 0.87, 0.89. So what we want to be able to do is we want to look at our history and be able to plot the loss versus epochs of our validation, and our validation accuracy versus epoch, and then also the loss and the accuracy of our test data. So if we do this, we can see, well, that's funny, isn't it? We don't have an imported pandas, so I'm going to say import pandas as PD, as, excuse me. And then so now we can see our table. So our history has these tables of our validation loss, validation accuracy, or less, and our accuracy. And these are our headers. And we're just looking at the bottom few of them. So now we want to be able to plot the loss versus epochs and the accuracy versus epochs. So we're going to import our library matplotlib as plt. And then now our history is going to be the history dictionary. And from this history dictionary, our loss values is going to be the loss column. Our loss values is going to be the val loss columns. Our accuracy is the accuracy column, and our validation accuracy is the validation accuracy. And the epochs is going to be going from 1 to the length plus 1, because right, pandas index is at 0, so this is 0 through 19, but we really want it to be 1 through 20. So we're going from 1 to 19 plus 1, so 1 through 20. And then now we can go ahead and plot our data. So we're going to plot the epochs versus loss value. It's going to be plotted in blue dots. The label is going to be the training loss. And then we can do, or that's going to be, yeah, the training loss. And then we can do epochs versus validation loss. It's going to be blue lines, validation loss. We can label our axes and plot it. And then so we can see here, we're overfitting our data, because as our validation loss increased, our training loss is always going to decrease, right? Our training data is always going to reach perfection, so we're going to have 0 loss in that. Whereas our validation, the validation data is the data that the sample has never seen before, or the model has never seen before. It starts doing pretty good, and then it starts to overfit, because we're training on only the data only on the training data, and it's not seeing the validation data at all. And then we're overfitting it. So our model cannot fit the validation data nearly as well as it can fit the training data. And we can look at the accuracy and plot that as well. So right here, you can see our accuracy definitely tops out right here at about 3 epochs. And then the accuracy of our training data reaches perfection, but the validation maxes out right here. And so we're going to rebuild our model and only use 3 epochs. That way we can get our highest amount of accuracy possible. So it's the same model we had before. We're going to rebuild it, but now our epochs is going to be 3. And then finally, we're going to print, we're going to evaluate the model on the test data, the data it hasn't seen before. So that's our Y test and our X test. And then we can print the results and take a look at those as well. We're going to print the results from that, from applying the model on the X data and the Y data, the test data. And then so our accuracy is about 88%. And we can look at the values here. So our accuracy was 88%, which is pretty good considering, you know, we have a very simple neural net that we have. And so we can probably improve on this if we want to add more hidden layers and change the amount of hidden units that we have in our sample. And then now here's our test data. And so, right, we're going to round these to either 0 or 1. And so some of these are obviously a positive review. Some of them are obviously a negative review. And some of them, you know, are kind of on the border. You know, so that's probably where the uncertainty is in our model. So that's the end of this tutorial. Thanks for this walkthrough. And this is going to help you with your assignment when you have the what assignment is it? I think it's the, oh shoot, I'm drawing a blank now. Well, you guys will find it. One of your assignments. Thank you for watching.